So, in today's session, we are going to see the basics of geological mapping. Now, let us observe this geological map. What we are getting here, there are basically two things we are shown, which is shown in this map. One is a dotted lines, and other one is solid lines. So we closely observe all these things. So there are all these two lines. If it is a solid line or it is a dotted line, everything is running parallel. If you see this line, this is running parallel to this line, and this is parallel, and this is parallel. Everything is running parallel, and this is basically a dotted line. There is some printing error. Okay, so this is what. So what is the primary interpretation what we can get from this geological map? From the geological map, there are two things. One is lithology is shown, and which is shown by the lines which is solid lines, and there is contours which are represented by dotted lines. So contours will always have the value on it, and it represents as a dotted line. Because why is it dotted line? Because contours are imaginary lines, so that is not the solid fixed lines. I can, instead of in 330, I can draw a contour of 340. So that is what I decide while doing the surveying, and that is an imaginary line. Because it is an imaginary line, because it is an imaginary line, I keep that value as a dotted line. Whereas the lithological boundary is a solid line because it is a fixed lithological boundary. At a particular level, there is one rock type, and immediately after that particular layer, there is a change in the rock type. I don't have any, as a surveyor or a geologist, I don't have any role to change that. I cannot change that. So that is a fixed line. So in most all the cases, when there is a dotted line that with a value written on that, that will be indicating the contour, and a solid line without mentioning the clear values, that will be indicating a lithological contact. So what I am talking about here, so this is a lithological contact. So this is a contact between sandstone and conglomerate, and this is another lithological contact, which is a contact between shale and conglomerate. Contour I am talking about, this is the contours I am talking about. So these are the things which is shown in the map here. So if you see this kind of map, first thing is that to have a clear understanding about the contour and the lithological boundary. Now after this, try to get an idea, what are the areas, what are the maximum and minimum areas shown in this map, or what are the if I cut this map into two equal halves, which part of this which section, which line of this section will cut or across maximum lithological contacts and the maximum contour values. So while looking into that, I will come to know that okay, this is the best area because it comes over to be the maximum layer. E, D, C, B, A, all the layers are cutting across, and that is also cutting across the maximum and minimum contour values 330 and 150. Alternately, if you take another option here, another option here, okay, or if you take this way, or if you take this is not coming E layer, but there is A, B, C, D layer coming. So they have different alignments, different sections I can visualize that it is cutting across all the different layers and cutting the maximum contour values. So for the time being, what I am considering here, I am considering an alignment that is I mark two lines, line A, point A and point B, which is cutting across the region, which is cutting across the maximum contours, and which is cutting across all the layers of rocks. Instead of giving particular name, here it is given A, B, C, D and E for the rock layers. Some representative names are given in the geological map here. Clear? So this is point B, point A and point B, and I kept my scale over this A and B, and I am going to draw a line which is connecting between point A and point B. So once I connect this point A and point B, this is what we call it as the section line. What is the idea is that you must have studied the sections in building construction. when you have a plan, you make the section. What is the section? Section is the cross-sectional view of the buildings. That is the same thing here. It is going to happen here. What is the section line means? I am assuming I am cutting this region along this line AB, and I'm going to observe this region, this line, this area from the sectional view, from the front view, okay, or from the sectional view. That is what we call it is a sectional view. So this across this line, I am going to cut this hill. This is a hill or valley, whatever, maybe I don't know what it comes up. Let us see that what it is going to come after we prepare the section. Now this is valley, along with I am going to cut this region, and I am going to observe the rock layers in this area. So after making this line AB, what we need to keep is that you need to keep that measure that distance, that is a line, the distance between A and B, and take the next side, the other side of the page, because in my case I am keeping my geological map on the upside and I am drawing the section on the downside of the page, and keep that same scale, and it was coming around 14 centimeter in the map or 17 centimeter in the section. So draw that same line on this geological map, and here need to produce the section elevation, that how much would be the height of that region. So this length of this line should be same, length of this line should be same as of that we have seen in this line, this length, this is the same line, what is having the same length. So this, how much we need to put this, we are going to calculate that. For that, how much would be the projection, how much would be the elevation we have to consider. I need to identify what are the maximum contour in this area. So that is 330, that is the maximum height of the hill in this area, and what is the minimum height of the hill in this the region, that is 150 meter. And what is the contour interval? What is 270 minus 330, 330 minus 270, that is coming 60. 270 minus 21, that comes out 60. 210 minus 150, that comes out 60. So the contour interval is 60. Now I got the maximum, minimum, and the contour interval. Contour interval we are not going to change, that we have to keep as it is. But for the section, what we are going to do is that we are going to consider the value in the region for the section preparation, that is the maximum contour value plus the contour interval. Maximum contour value was 330. Okay, so that would be the maximum value I am going to mark here, and the minimum would be 150 minus 60, that would be 90. So I add these all values here, and here I can take a proper scale, 1 centimeter, 2 centimeter, 3 centimeter. So 1 centimeter vertical may be representing 60 meters, 2 centimeter may be representing 60 meter, 3 centimeter may be representing 60 meters, something like that. You can take an appropriate scale. Here I am assuming that 1 centimeter is representing 60 meter. So the minimum contour is 90. So I can even start from here also 90, because I am taking, but I took one step ahead, one line up, one unit up, that is 90. Then we have the second, it is 150, 210 and 270, 330 and 390. So similarly on the both the sides I am marking this values. Okay, so this is my what is called, this is my boundary, this is the extent of my section and the height of my section. Two things I have already decided, I prepared. Now I need to just project that values, that contour values here. But in here, in this case, the distances are not uniform, or the distance between two contours, the height between two contours or the contours intervals are going to be uniform, but the distances between these contours are not going to be uniform, and it is not proper value. For what as a geologist we do is a small trick. And what is the trick? The trick is we take a small strip of page, tear any small strip of page from your A4 size paper, and I keep that strip of page on this line AB, and I mark this line A and line B. Then I identify that what are the areas where this contour is intersecting this sectional line. So here it is intersecting, and what is the height of that value, what is the value of that contour, that is 330. I say noted down that. Then I see that it is 270 contour is intersecting on this part, and then I see that 210 centimeter contour is intersecting on this part, then 150 intersecting on this part. I firmly draw a line on this strip of page, okay, and I marked this line and I wrote these values on the on that strip of page. Now what I will do, I will take this strip of page, and I'll keep that strip of page in the section. Where keeping the section, I'll make sure that this is A and this is B. The boundary or the length of line AB should be same, and I will keep this strip of page on the cross section. And first I will keep this page at a height of 150 meter, and then I plot the point 150 on my section view. Then I will keep this page on 210 meter. Then I plot the value of 210. Then I will keep this strip at 270 and I plot the value of 270. Then I keep it at 330 and I plot the value of 330. Okay. Now all these points I have plotted on my section. Now only thing I left with is joining these points using a freehand tool. And while joining these things, you have to keep two things in mind. First thing, that the maximum value is 330, but while breaking the section we took up to 390, but the 290, this surface is not intersecting, so this point should join below 390. And the minimum value of contour what we are getting was 150, and our surface was never going below 190 meters. These are all meters, 90 meters. So this joining should be above the 90 meters, and this surface should be as far as possible should be a smooth freehand drawing. Should not join straight lines. Should not be a straight lines, because this is a natural surface. Okay, so this natural surface should be freehandly drawing, and wherever it meets to the joining, it should join to the border, but make sure that it is not going above this 390 and 190 meter below. Okay, now I come to know that the sectional view of my study area or my geological area. Now what I left with is plotting the lithological contacts, and from the previous study I came to know that my lithological contacts are horizontal because these lithological contacts, all these lithological contacts are running parallel to the contours. But here the values of these lines are not given. So what we have to do is that we have to go for a interpolation method, because this is the value of 210, this is value of 150, measure the distance, and this represents a 60 meter variation, and then measure the distance of this and convert that to a meter. Okay, so this interpolation method we can adopt here, but for the time being what I am doing here, I am assuming the values, because the value is almost middle of these two values, 150 and 210. So I am taking this value, this is 180, and here I am taking this value, it is 240, because it is between 210 and 270, and I am taking which is between 330 and 270 as 300 meters. So I take that same strip of page. So I am having the first lithological contact, that is between rock type A and rock type B, is at what height? At a height of 180 meters. So I will draw that line on the geological map or geological section. So 180 means this is 150, this is 210, so 180 will somewhere here. So I draw that line, and I'll make sure that line doesn't go outside the surface. So this is to be drawn till the surface only, because outside the surface, if the area has already gone, there is no rock seen. Now the second contact was, this is A and this is B. Second contact was at 240. So I draw that line at 240, that will be the rock type B, and the third line will be at 300 will be C and D, and 360 I'll get the rock type between E. So I got A, B, C, D and E. So this is the basic cross-sectional view of my area. So So from this geological map, I can interpret that the area is having 6 layers which are in horizontally arranged, and the maximum height of the region goes around 380 meters and the minimum height of the region goes around 100 meters, and it is a gently sloping region. And from the geological history, I can even interpret that these all rock layers must have deposited as a horizontal layer in this region, and due to the weathering and erosion processes, this area have gone, and as a result these rock types have created a topography something like this. So there is no indication of structural feature, and if you know the characteristics of these rock types, physical characteristics or the mechanical characteristics of this rock type A, B, C, D and E, I can even decide at what depth my foundation would go for, whether I would be able to consider this region for a construction of dam or not. All the different factors I can understand from the geological cross-section. So similar geological cross-sections may be prepared for number of sections like we have created here. Similarly, I can create another cross-section this way, so that will give the slope and the characteristics of this region in this way. And if you can go for a section on this way also. So number of sections if you prepare, then I'll come to know that the actual characteristics of rock types and where it is sloping, where it is layers are increasing, decreasing, all that characteristics of that region I'll be able to interpret from this geological map studies. And this is what one of the important thing for any civil engineer. You will get a geological cross section of that region, and that geological cross section need to be studied while doing any major construction activity.